Welcome back, Math Marvels. This is lesson 99, and in this lesson we're going to write a rule for an arithmetic sequence. So it's like an adding sequence, getting bigger or smaller. So here's our criteria for success. We're going to consistently find the common difference. In other words, what is the difference between one term to the next, and making sure that it is consistent throughout, and being able to identify that pattern as either an addition or a subtraction pattern between consecutive back-to-back terms. And then we're going to substitute that D, that common difference, into that first term for our explicit or recursive rules. High level, just looking at our notes in terms of writing an explicit and arithmetic sequence. Here's what we want to do. Again, we want to find that difference between consecutive terms. So you have to use back-to-back numbers. And when you notice what's the difference between them, is it getting bigger or smaller, and by how much? If you see that that is happening time and time again, then we will call that a common difference that we can write as D. And we can have recursive or explicit rules for this, just like we learned in our last lesson. So I'm going to give one that you could actually see. Here's one where the common difference, I can have it as the previous term plus the difference, and that's what we were thinking about recursively, right? So the previous term and the difference. And the difference could be a negative number if the number is getting smaller. Or in this case, we're starting, for the explicit rule, the starting number, and then you're taking the difference times the previous term. So that's the difference here. So let's try to figure out what this means, because that sounds really complicated, but I think we can break this down. So here's a sequence. It's just showing a bank balance every single month, and we're going to use the recursive rule. And I kind of wrote it on the bottom, but what I want us to be able to do is look at the difference between numbers. And this is, again, how you were thinking since you were younger. How are numbers changing? We're always thinking about that. How are they changing? And so here you'll notice that these two numbers are changing by 20. And notice I'm picking consecutive back-to-back numbers. Again, they're changing by 20. I'm adding 20. I'm adding 20, I'm adding 20. So that means my common difference, and it's common because it is consistent, is 20. Okay, D is equal to 20. So we can write that as D plus our previous number. All right, so the difference plus the previous term. It's the same thinking that we've been doing. I'm just changing the language a little bit and making it a little bit more sophisticated. I'm just using math terminology, but it's the same as previous term plus that change, that new rule. So hit pause and jot this down into your notes. Let's look at the explicit rule a little bit more and just break it down. So we have our initial number, our start, we have our common difference, D, and then we're figuring out how many times are we adding D. All right, so how many times are we going to do the plus 20, plus 20, plus 20, plus 20? That's the goal here. So here, our D is still adding 20, so our D is still 20. But let's say I wanted the 20th term, where an n equals 20. Okay, so I would do, let's write our original part in there. Let's actually give ourselves a little bit of space here. So I want the 20th term. I'm going to do my first number, F1, plus D times 19. Why? Because it's 20 minus 1. So I'm only going to add 20 19 times. Okay? Because that means I'm just going to keep doing this. Plus 20, plus 20, plus 20, plus 20, plus. Then I'm doing this 19 times. So instead of just adding it again and again, I'm just going to do 20 times 19. So I'm starting with 60 plus 20 times 19. 19 times 20 is 380 plus 60, and that gives me 440. And look at how quick that was to figure out the number. So again, I always have a preference for the explicit rule. I try not to say speed is king, because I don't think it always has to be, but I will say there is a level of ease to being able to use the explicit rule versus if I had to figure out the 20th number using this rule. That's just me. I wouldn't want to have to figure out the 19th number and then add 20. So again, hit pause and jot this down into your notes. All right, let's jump into our guided practice. Again, representing that repeated addition or that repeated subtraction with multiplication, super helpful. So work into this one. The table shows the number of members in a theater group after n weeks. Write a recursive rule and an explicit rule for the arithmetic sequence. If you need to, go back into your notes. Okay, let's work on the reveal, and for both we do need to know what D is equal to, and you should have noticed that it is increasing by 12. So D is equal to positive 12. So writing off our rule, let's start with the recursive. The recursive, f of n, would be equal to our common difference plus our previous term. So difference plus previous. In this case, that would be 12 plus f of n minus 1. And our explicit rule for this one would have been our first term, f of 1, plus our difference times n minus 1. So now we would just substitute in. Our f of n would be 35 plus 12 times n minus 1. And we're going to leave it just like that. Now, some people may be thinking, we've done so much of distributing, could I distribute this and write another rule? Why, yes, you can. So this is another option. You could have written 12n minus 12 and simplified out. But for right now, I will say that this is sufficient. But if you were thinking of distributing, that would be just another rule, an equivalent rule that could express this sequence. All right, that's it for today's lesson. Use this to practice, find a common difference, and I will say that using the explicit rule to find n when it is a larger number would be most helpful. That's it for today's lesson, Math Marvels. Be well.